Exercise 413 is giving you the names of bicyclic compounds and asking you to draw the structure of the compound. With these, I would encourage you to start with the bridgehead carbons. So you'll have one bridgehead carbon and another bridgehead carbon right there. And what we have inside of the brackets are the number of carbons on each side of the bridgehead carbons. So for example, on one side of the bridgehead carbons, there are 2 more carbons. And so we can draw those in, 1, 2, and connect it back. On the other side of the bridgehead carbons, we have 2 more carbons. So we can draw those in, 1, 2, and then connect them. So those are our 2 carbons there. And finally, on another side between the bridgehead carbons, we have a connection with just 1 carbon. So just 1 carbon there, and then it comes back down. Now let's make sure we've taken into account all of the carbons we need to. We should have 7 total. So we have 1, 2, 3, 4, 5, 6, and 7. So the prefix hept makes sense, 7 carbons. All single bonds, so AN, and then it's a hydrocarbon, so E. So this is the backbone. This is bicyclo-2,2,1 heptane. Now we just have to put our branches on there. So we've taken into account this whole part. When you number these, you have to start numbering the largest branches first, and so the orange and the yellow part, you have to start numbering the largest parts of the ring first. The orange and the yellow rings are the same size, so we could start numbering either place. We start at one of the bridgehead carbons. I'm going to do the orange one first. So once you number the bigger sides of the ring, then you go to the smaller ones. So that's a legitimate way to number that bicyclic ring. Now we have 4 methyl groups. A methyl group has just 1 carbon in it. It's a branch with just 1 carbon in it. So we have 4 of those, and they're going to be attached to those positions. So we have 1 methyl group coming off of carbon 2. We have another methyl group also coming off of carbon 2. We have a methyl group coming off of carbon 3, and another methyl group coming off of carbon 3. And so this compound is your structure. This is 2,2,3,3 tetramethyl bicyclo-2,2,1 heptane. Let's try to go through that same process for this next one. So I encourage you to start with the bridgehead carbons. Draw those in. So you have 2 bridgehead carbons. What the numbers in the brackets are telling you are how many carbons are on each side of those bridgehead carbons. So on one side we have 3. So we'd have 1, 2, 3. So 1, 2, 3 carbons to the left, for example, of those bridgehead carbons. And it would have been okay to put it to the right or to put it up. I'm just putting it to the left. Now on another side we have 2 carbons. So 1, 2. 2 carbons on one side. And finally, on another side, we have 1. So, just 1. Now, if we've done it correctly, our prefix should make sense. We should have 8 carbons. So let's count these up. We have 1, 2, 3, 4, 5, 6, 7, 8. Looks good. Okay. Now, we have all single bonds, so the AN makes sense, hydrocarbons, so the E makes sense. So far we've taken into account the bicyclo-3,2,1 octane. We've drawn that. Now we just have to add in our branches. We have 2 branches, and they're both on carbon number 8. Now when you number these rings, you have to start numbering at the bridgehead carbons, so I'll start numbering at that one. I'm drawing the molecule, so it doesn't matter which one I start at. I'm going to start at the back one. But when you number bicyclic rings, you always have to number the largest ring first. Now the orange part is the largest ring here. It has 3 carbons in it. So we're going to go around that ring first. Now I could either go to the right for the yellow ring or up for the blue one. The yellow one has more carbons. It has 2. So I'm going to go around that way. And that means that the top carbon is number 8. So that's where we're going to have branches. Now our branches, the prefix for our branch is F, which means each of our branches should have 2 carbons. The YL is just telling you that it's a branch. So we should have 2 carbons, 2 carbon branches, and they're both going to be coming off of carbon 8. So the first one, here's a 2 carbon branch, 1, 2. Second one, here's another 2 carbon branch coming off of carbon 8, 1, 2. And that is our whole structure. We have 2 ethyl branches coming off of carbon number 8. So that's 8,8-diethyl. We have our 2 rings with the correct number of carbons in between. This is 8,8-diethyl bicyclo-3,2,1 octane. I think this third one, C, is the last one like this for practice. So again, I encourage you to start with the bridgehead carbons on these bicyclic compounds. So you always have 2 bridgehead carbons here, and the numbers in the brackets tell you how many carbons are on each side of those. So for example, if we have 3, that means we have 3 carbons on one side of those bridgehead carbons. So 1, 2, 3. If our next number is 2, that means we have 2 carbons on another side of those bridgehead carbons. So 1, 2. And then if our third number is 0, that means we have no carbons in between those. So that would be the skeleton for that. Now if we've drawn that correctly, our prefix should make sense. We have hept, and that means we should have 7 carbons. Let's see. 1, 2, 3, 4, 5, 6, 7. So it seems like we have a good structure. All single bonds and a hydrocarbon, so we don't have to add anything else to that parent chain. So we've taken into account bicyclo-3,2,0 heptanes so far. Now let's think about the branch. When you number these chains, you always have to start at one of the bridgehead carbons, and you want to go to the chain with a higher number of carbons first. So for example, the orange side has 3 carbons, the yellow side has 2. That means we need to number the orange side first. So we'll start at one of the bridgehead carbons. Doesn't matter which one you choose, you're drawing the molecule, so you get to choose. And then we have to number the orange first, because it has more carbons on it. So on carbon number 3, we're going to have that isopropyl group. Remember, that's one of those branches with branches. That's where you have a sort of snake's tongue and only 3 carbons total in the molecule. So notice snake's tongue and only 1, 2, 3 carbons in the branch. I'm sorry, I said molecule. Should have 3 carbons total in the branch. And so that's it. That would be 3-isopropyl bicyclo-3,2,0 heptane. Beautiful.